Distinguished speaker, Edmund.
We have a 3-star here. The General Susan Helms is the commander of the 14th Air Force Space Command, and commander of the Joint Functional Component Command for Space, U.S. Strategic Command, Vandenberg Air Force Base, California. General Helms leads more than 20,500 personnel responsible for providing missile warning, space superiority, space situational awareness, satellite operations, space launch, and range operations. General Helms was commissioned from the U.S. Air Force Academy in 1980. She served as an F-15 and F-16 weapons separation engineer and a flight test engineer. Selected by NASA in January 1990, General Helms became an astronaut in July 1991. On January 13, 1993, then an Air Force major and member of the Space Shuttle Endeavour crew, she became the first U.S. military woman in space. She flew on STS-54 in 1993, STS-64 in 1994, STS-78 in 1996, STS-101 in 2000, and served aboard the International Space Station as a member of the Expedition 2 crew in 2001. She's a veteran of 5 space flights. General Helms has logged 211 days in space, including a spacewalk of 8 hours and 56 minutes, a world record. General Susan Helms.
Thank you. It is kind of an impressive sounding resume. I recognize that, but I would tell you that the only reason I'm standing up in front of you today with that kind of resume is obviously because of the people who reached out to me and mentored me when they recognized that I was a STEM student in the making way back in 6 and 7 years old. That I would not have the resume I have today if not for the fact that there were those around me who were encouraging me to pursue math and science at a very young age. And I thought I'd share with you a couple of key moments that happened to me in that process. And of course what I'll do is I'll ultimately roll this up into strategically where we're all what's all happening and where we're going. I basically had the fortune to grow up in a family that was very encouraging of young girls. And I had 3 sisters. All 4 of us are very, very strong women. My dad is a very proud Air Force pilot. My mother is extremely strong. I'll tell you that when it comes to math and science, she was the one in the family that was balancing the checkbook, not him. So way early on, when basically the secrets of the multiplication table was unlocked to me, was when I realized I had a knack for math. And the beauty of this is when I was at that young age, which was literally 6 or 7 years old, I was surrounded by people who basically thought that was really neat that I was good at math, not really odd. And my theme throughout my entire presentation today is really about the power and the empowerment of encouraging people at a young age to do math and science. And I'm sure with the audience I'm speaking to and who you are and what you do today, this is a message that I know all of you know deeply. This is one of my favorite audiences, by the way, to talk to. I love talking to the education field. I love analyzing how young people get the way they get by these early years and the kinds of things that happen to them in their environment. My mother is a teacher. She ended up teaching math and science when she was basically teaching 6th grade all the years my dad was in the military. Everywhere we went, she got a teaching job and picked up where she left off teaching math and science and English. So you're my favorite audience, and already I'm feeling the love from the standpoint of being able to talk this topic with an audience such as you. And I think we all know that in today's world, we're basically living in a challenged world when it comes to encouraging math and science. And I think back on what it meant to me when I got encouraged, and there were a couple of key moments that happened to me in my youth. For example, and this one is a little strange. When I was 11 years old, my dad was stationed as a pilot up in Massachusetts. And one night,
I remember Mom and Dad having a discussion at the dinner table and saying, well, this is really a big deal. Should we wake her up? And my dad said, oh, don't wake her up. She won't really know what's going on. And my mom was like, no, let's wake her up. Let's bring her down when it happens. And they didn't wake up all my sisters. They just woke me up. I don't know why. But they woke me up to watch Man Walk on the Moon. That's what the moment was. And even though it wasn't in my mom's nature to get the kids out of bed for any reason, once she put them down to bed, she thought for whatever reason that night, 20 July 1969, I was 11, she thought that was a very important thing for me to see. Historic, obviously. I think you'll appreciate this part of the story. When I came down, I acted like it wasn't a big deal. And they could not tell whether or not it was worth the effort by looking at me and how I looked. I watched, I was completely silent. I took it in, and then I basically said, okay, I'm going back to bed. And they couldn't tell. They couldn't tell what sunk in, I think. And all of you who are educators, I think, can fully appreciate the fact that sometimes you don't always get that feedback from the target, if you will, about what it is you do and whether or not your messages are getting through. I think they are. I have run across people I knew who were students in school 20, 30 years ago when I was teaching at the Air Force Academy as a captain in the Air Force. And I was teaching aerospace engineering, so I was, again, deeply embedded in the STEM business. And when I run across my former students today, some of them I ran across at NASA, sitting in mission control. My class, they got a D, so I didn't think it slipped in. But there they are, working in the front room of mission control. Obviously something snuck in there and got them motivated, but maybe it was the D I gave them that got them motivated, I'm not quite sure. Or maybe I should have just been scared that they were in the front room of mission control. But my point is, I got lots of feedback, literally 10 or 15 years down the road, about the fact that the things I said in the classroom and the enthusiasm I had about teaching aerospace was inspiring to them. And they remembered it. And even though, to me, my memory is looking at a bunch of deadwood out in the audience, as the kids sometimes can present to you. You know how it is. There's always that 10% that's super excited, and they're nodding their heads up and down. There's always that 10% that's asleep, and then there's that 80% in the middle where you can't tell whether or not they're taking it in. And I know that's what you see because I was also a teacher for a while, and I know that's how it works. So, but it worked. It basically, I had no idea of the impact that I had even at that moment, and I think we have to keep that in mind, that this is not one of those areas when you talk about being a mentor and being in a position of encouragement and being in a position of support and inspiring. This is not an area where you get that instant feedback from the kids most of the time. I think a few cases you do. In some cases the kids will wear you out telling you how inspired they are, but I think basically we have to keep this in mind, and that's really my key message today, is never losing our focus on that, because you never know when you said a particular thing that made an impact on the folks who basically were there listening to you. After I became an astronaut, I had all kinds of opportunities to put my math and science skills to work. I basically, first of all, the space shuttle, by the way, is a marvel of thermodynamics. It launches off the launch pad at Kennedy Space Center, as you all are well aware. It goes through a very dynamic thermal environment by going from the 85 degrees of Florida all the way up to the vacuum of space, which is in many cases around the minus 200 degree range. And then it orbits the Earth. And as it goes through an orbit, every 90 minutes, it goes through a thermal cycle. Every 90 minutes, it goes through being shined upon by the sun when you're on the bright side of the Earth, and then it goes into the darkness, the cold, cold, cold darkness at minus 200 degrees on the night side of the Earth. And it basically does that 16 times a day while it's in orbit. And the space station, by the way, is doing that even as we speak. And it needs to basically be mastered from an engineering perspective in order to manage those thermal cycles which are some of the most challenging engineering problems that we basically have as we talk about doing things in the space environment. There's a lot about the space shuttle that's engineering marvels, but the thermodynamics part to me is particularly masterful because you cannot replicate necessarily on Earth some of those thermal challenges. And the shuttle has been designed by Americans to basically manage that problem set over and over and over again. Of course, and then after you actually have the shuttle mission, you have the re-entry. Another very interesting dynamic thermal problem. And the technology of Americans today, basically the tiles and the other aspects of the space shuttle that can survive the re-entry, that all came from people who were trained in math and science and enjoyed the challenge of expanding the boundaries of how we could operate in those kinds of very dynamic thermal regions. So I always marveled at the talent of the engineers that we had in place at NASA. I marveled at the talent of the engineers who could build a spacesuit that basically kept me alive during my spacewalk. I mean, I think you've all seen those white suits. They're all over the news, of course. They're basically self-contained satellites. The only thing that keeps you from being a total and complete satellite is the tether that keeps you attached to the space station or the space shuttle. But inside those suits, there's oxygen, there is a carbon dioxide removal, there is water, and the water is basically used to keep the human being inside at a stable temperature. You wear liquid-cooled underwear, and in this underwear are all kinds of tubes. And it's a marvel of engineering that as you do a spacewalk and you continue to be exposed to the thermal cycles of going around and around the Earth in your spacesuit, that inside the spacesuit you can basically manage to keep yourself at about 70 degrees the whole time. The hands get a little cold at the extremity level, so they have little hand warmers. Actually, they have big hand warmers now that I think about it. But the bottom line is, again, it's a marvel of engineering that made that kind of experience possible. Worth noting that the robotic arm on the space shuttle and the robotic arm on the space station are also marvels of engineering. I just had the wonderful opportunity to sit with these young folks who won the robotics award at the international level, and I just couldn't be more proud of them watching. They're in the back there. Why don't you all stand up so you can be recognized. And more importantly, the people that have been encouraging them to go after these feats. Larry and Jan, would you also stand up and be recognized?